No human has ever witnessed an eel reproduce in nature, not once in the wild, never in captivity, not a single time. Yet eels exist everywhere, in streams and ponds and seas, slippery, primordial, and inexplicably present. For thousands of years, humanity's brightest minds attempted solving the eel enigma. Aristotle believed they spawned from Earth. Others claimed they manifested spontaneously, created by sunshine and moisture. Even now, there's just one location on Earth where we believe every eel originates. Somewhere deep in the Atlantic where, strangely, no mature eel has ever been discovered. So why are eels like this? What survival benefit exists in such an impossibly elaborate journey? And why does their life cycle still contradict so much of our biological understanding? This isn't simply a fishtail, it's about a creature that violates science's fundamental rules. After millennia of guesswork, the eel mystery was no longer merely philosophers' curiosity. It became scientists' obsession. By the late 19th century, researchers launched fresh eel experiments, including additional dissections and lab observations. But despite evolutionary science's new insights, their findings hit dead ends, meaning the eel puzzle persisted. As 19th century German poet Leopold Jacobi described,
"It is somewhat humiliating to men of science that a fish, which is commoner in many parts of the world, which is in the market and on the table, has been able, in spite of the aid of modern science, to shroud the manner of its propagation, birth, and death in darkness."
This only intensified attention, and now the world's premier scientists were racing to first discover something fresh about this illustrious creature. In Trieste, Italy's scenic harbor, an ambitious teenager was determined to finally solve it. He utilized Mediterranean coast eels, testing his observations. He sat recording findings in a cramped room with one window, a microscope at his cluttered workbench's one end, and a glass dissection tray at the other. The remaining bench was buried under chaotic items containing his study specimens. Dozens upon dozens of eels, he spent countless solitary hours in his laboratory, his clammy hands drenched in briny eel slime and seawater. In 10 years, he'll be recognized as psychoanalysis's founder, Dr. Sigmund Freud. But here, in spring 1876, he's a 19-year-old medical student with zoology interests. On assignment by his doctoral supervisor, he traveled to Trieste from Vienna's university. There he established an unusual, diligent routine sparking his research practice interest. Every morning he ventured to docks, buying freshly caught eels from local fishermen. Then he returned to his rented quarters and dissected them for hours, slicing open their bellies and probing their innards under his microscope. Freud continued this routine for months, cutting open countless eels. Consumed and exhausted by his work, he once wrote a friend,
"My hands are stained by the white and red blood of sea creatures. All I see when I close my eyes is the shimmering dead tissue which haunts my dreams."
At his letter's end, he enclosed a simple eel drawing, mouth slightly upturned, as if slyly smiling at successful secret concealment. Like many predecessors, young Freud searched for eel gonads. Specifically, he sought the eel's male reproductive organs, the sperm-containing testes. A female eel complete with egg-laden ovary had been discovered just over a decade earlier, but no such evidence existed for a mature male counterpart. Freud would ultimately never find conclusive testicular evidence in an eel, and his name joined the failure list. Embarrassed, he published a brief paper and set the question aside, never returning to it. Freud was hardly the only thinker puzzled by eel origins. With zero progress, hence, several attempts bridged our eel knowledge gaps. Ancient Egyptians thought eels appeared in the Nile when sun warmed its waters. By ancient Greek times, the eel mystery was so renowned that Greek poets joked that since children with uncertain paternity were ascribed to god Jupiter, eels must be his offspring. Even Aristotle tried, describing eels emerging spontaneously from Earth's entrails when soil mixed with rainwater. Along the British Isles, folklore tales spoke of eel origins from numerous natural world facets. They were born of sea foam, crystallized from spring dew at sunrise, animated from horsetail hairs thrown into moving water. Some thought eels might reproduce asexually. Roman naturalist Pliny the Elder proposed new eels formed from skin flakes scraping off older eels when they rubbed against rocks. Middle Ages stories depicted the eel as a hybrid creature, sometimes both fish and serpent, but also both male and female, enabling a single eel to somehow self-fertilize and bear offspring. Others thought eels must transform from some entirely different creature, as with a Scottish folk belief that eels began life as beetles, developing within and emerging from the carapace when ready. But all these myths were just societal imagination products. Reality was something far deeper. As we know today, eels don't start as beetles, yet there may be something to the transformation creature idea. While no tangible reproductive progress was made in the 1770s, scientists did have one victory. Due to stark differences between the eel's earliest larval form and its adult counterpart, it was initially classified as an entirely new fish species under genus Leptocephalus. Thus, eel life cycles remained obscured so long partly because of their dramatic metamorphoses, a life history of shape-shifting with a secretive repertoire of past selves. Imagine believing the tadpole to be a completely separate species from the frog it develops into. On land, such organism transformations can be studied easily. In the ocean's vastness, such mistakes seem rather easy making, but late 18th century scientists finally figured out the connection. Thus, new larval stage evidence was found. The eel's life begins as one of billions of tiny glassy specks suspended in deep blue sea. Half-blind, and at the current's mercy, they float through endless ocean. Their fragile bodies unfold like a new spring leaf, showing a transparent form just a few millimeters long. Most of its body is made of clear, jelly-like tissue, which later shapes its adult form. Its main features are a thin white gut running down the middle and a tiny head with eyes and a jaw. This is a Leptocephalus larva, the eel's first life stage. From birth, these tiny creatures trust the sea guiding them. Wind and waves cradle them, forces beyond their control. Carried by the Gulf Stream, they drift from vast ocean toward European shores. Along the way, they survive on marine debris bits or phytoplankton swept into currents. Being born this way feels like a faith act. Despite the sea's challenges, they follow its rhythm, trusting it will bring them where they need going. Their journey can last years, as oceans slowly return them to shore, continuing an ancient path followed by eel generations before them. The young eel arrives on European shores looking very different. By this time, it's already undergone its first metamorphosis, transformed into a glass eel. Its flat body is now longer and slimmer, closer to its adult form. After drifting with the current for years, it now faces swimming against it. Emerging from dark salt water, the eel swims upstream into estuaries. Using the water's power that gave them life, glass eels make their way toward fresh water. They crawl through wet earth, cling to logs or stones to climb, and even grab rocky cracks to scale waterfalls, moving slowly but steadily. En masse, they spill into every freshwater body possible: rivers, streams, lakes, ponds. After 2 arduous journey legs, the eel is ready, starting life anew. Here in freshwater, it's reborn again. The translucent jelly of its body becomes speckled with pigmentation, metamorphosing into an elver. While once content sampling varied appetizers of marine detritus, the elver develops a voracious appetite. In the riverine systems it now calls home, it devours small invertebrates, preparing for its next growth season. With ample energy supply, the elver grows stronger and sturdier. After 2 years of freshwater life, it matures into a yellow eel. Unlike the elver's quivering jelly-like body, the yellow eel's body is long and muscular, Where once its larval form was at water's mercy, the juvenile eel slices through it like a knife. It doesn't fear drought, dragging its belly through mud, finding new water bodies if its own runs dry. Against cold, it stays resolute, enduring harsh winters by going into deep hibernation. The yellow eel is the eel form people would be most familiar with. It was this hardy form that could be fished from a pond, found on dinner tables, or unexpectedly drawn from a well. For years, even decades, yellow eels remain unchanged. A humble but constant history part. What most couldn't possibly know was that the yellow eel wasn't the eel's final life stage. Decades after leaving the ocean, the yellow eel feels a familiar, inexorable pull. This is the eel's oldest song, an overwhelming instinct chorus transforming them one final time. This last metamorphosis carries certain gravitas. The yellow eel sheds its trusty olive-brown skin, worn for many long years like a workman's jacket. In its place, it dons a cold black coat with silvery underside, as if wearing a morning coat over a shimmering robe, an oddly appropriate combination for its last journey. Equal parts ceremony and funeral. Like an ascetic seeking enlightenment, they cease eating, their stomach dissolving away. But while saints and hermits sought freeing themselves of worldly urges, the eel gives itself entirely to ancestral forces driving its body. This process is known as silvering and results in the fully mature form, the silver eel. Fattened by its freshwater years, the silver eel will summon all its strength, retracing childhood's journey in reverse. The European eel is catadromous, meaning it returns from freshwater to saltwater to spawn. In preparation, its eyes become larger, more sensitive to ocean depths, dim blue light. Within its body, its reproductive organs, absent for so much of its life, begin developing. As an elderly traveler longs for home's comfort after a lifetime of journeys, the eel yearns for the deep blue-black waters where it was born. Just as it once drifted with currents in its youth, it now follows an instinct that cannot be denied. The need bringing new life into the world. At last, weary but determined, it's time returning home. The sea's call seems strongest under certain circumstances. When rivers are rain-swollen and earth damp with rain, when the moon is new and the night sky is dark, even human constructs cannot stop them from returning. Eels have been known escaping tanks, traversing roads and parking lots, and even scaling entire dams in order returning to sea. Immersed in currents helping guide them home, eels are thought sensing changes in salinity and temperature, as well as Earth's magnetic field for navigation. The European eel will undertake the longest migration of all true eels, traveling from 3,000 to 6,000 miles into the Atlantic Ocean. The odyssey culminates in the Sargasso Sea, named for brown algae drifting in its clear blue waters. There, eels congregate and spawn, releasing billions of eggs and sperm. After months swimming on their fat reserves alone, adult eels are exhausted. They don't survive this final journey's toll. After spawning, they die. Their purpose fulfilled, their silvery bodies surrender to the ocean's embrace, as if the sea's beseeching cry finally ceases and turns to gentle soothing. You're home now. You can rest. Soon their progeny, suspended in illuminated water, like dust in a sunbeam, will hatch. The cycle will begin anew. The intricate element interplay preparing once again to choreograph the life history of this singular fish. Who could have known that the humble eel that could be fished from any ordinary pond's muck was hiding such an extraordinary journey? It's unsurprising then that it took until the 19th century's end for us deciphering the first hints of the eel's ancestral odyssey. The first discovery step occurred in 1890 when leptocephalus's true identity was revealed. Coincidentally, about 100 years after it had been described as a separate fish species. Examining specimens from the Strait of Messina, Italian biologist Giovanni Battista Grassi found they possessed exactly 115 vertebrae. an anatomy only compatible with eels. He also achieved what Freud had failed accomplishing 20 years earlier, discovering a mature male eel with testes and sperm. With eel reproductive ability proof and leptocephalus recognition as eel larvae, Grassi had made the most significant eel biology findings in centuries. A few years later, scientist Carl Johan Petersen managed keeping a yellow eel in captivity at the Danish biological station long enough witnessing it metamorphosing into a silver eel. At last, the eel's many forms were known. Finally, it seemed like the millennial-long secrecy cloak obscuring eel beginnings was slowly falling away. It seemed inevitable that soon the eel would seem a stranger to us no longer, that we would understand how it lived. But following in the eel's wake led us into the unknown once again, a journey far vaster and more unbelievable than most thought possible. Common use of terms like elver, likely a corruption of eel fare, show that eel movements were not entirely unknown to us. The term refers to young eel passage upriver in large numbers. It was only during the return journey that they vanished from our sight. As silver eels left their freshwater domains descending into the Atlantic Ocean, they disappeared without trace into its depths. One scientist, however, remained unconvinced. Johannes Schmidt was a student of Petersen at the Danish biological station and would be first truly untangling the complex life history and eel origins. Writing in 1923, he posed the question,
We know then that the old eels vanish from our ken into the sea, and that the sea sends us in return innumerable hosts of elvers. But whither have they wandered, these old eels, and whence have the elvers come?
For Schmidt, this was no rhetorical question. His tireless answer search began in 1904 aboard research vessel Thor. He cast fine mesh plankton nets overboard, using them trolling shallow surface waters for fish larvae. He intended sampling cod fry, but spotted a distinctive larva among the rest, a single eel leptocephalus. It was 74 millimeters long, close to the larvae size that Grassi had found in Messina. But Schmidt wasn't anywhere near the Italian coast. He was sailing in the Atlantic Ocean west of the Faroe Islands. Schmidt couldn't believe his luck when he realized what his humble plankton net had caught's value: the first eel larva ever seen in the Atlantic. This singular larva was the beginning of a 20-year pursuit, a true pilgrimage made in the eel's wake. For 3 years, Schmidt combed the North Atlantic searching for the smallest leptocephali. Net by painstaking net, he collected eel larvae, mapping where they were found and where they were not. He recorded hundreds of measurements, hoping finding smaller specimens. Schmidt knew the prospects of finding tiny larval needles in the massive Atlantic Ocean haystack were daunting. To scour as large an area as possible, he even convinced Danish cargo ships sampling waters along their trading routes, hoping discovering smaller larvae. Over 19 long years after Schmidt dredged that first fateful larva from the Atlantic, his painstaking pilgrimage was finally at an end. Within the calm, clear waters of this sea within a sea, adorned by sprawling wreaths of brown sargassum algae, lay both the birthplace and the grave of the European eel, the Sargasso Sea. Schmidt returned to Denmark to much celebration, and to this day his conclusion that European eels breed in the Sargasso Sea remains uncontested. But for all his dedication, his conclusion was based on inference, not observation. In his 20 long years tracing the eel's origin, not once did he ever find an eel egg, and neither did he ever observe adult eel spawning. In the 100 years since Schmidt published his paper, many expeditions have followed in his footsteps. However, it's only within the last decade that researchers have successfully cajoled eels into giving up a little more of their secretive inner lives. In 2017, a collection of studies tracked a total of 80 female eels released from various European coast locations. Researchers used satellite tags tracking their migration paths, following the eel's journey for over 6 months until the tags detached. they witnessed eels travel astounding distances of over 3,000 miles before their paths began converging in the Azores, a group of Portuguese islands just over 1,500 miles from the Sargasso Sea. It was only in 2022 when researchers managed intercepting a few eels that began their migration off the Azores Islands coast. Of the thousands of eels making this journey, researchers managed catching and attaching satellite tags to 26, re-releasing them into sunny coastal waters. Of the 26 tags, only 5 stayed attached long enough showing their eel had ventured within the Sargasso itself's landless boundaries. Of these 5 tags, only 1 transmitted data from the Sargasso's heart within the eel's hypothesized spawning grounds coordinates. This lone beacon, surrounded by miles of wide-open ocean, is the most direct evidence we have of the European eel returning to its birth's ancestral grounds to spawn. Over a century since Schmidt's discoveries, no one has ever recorded or witnessed a European silver eel, alive or dead, in its birthplace's clear waters. The eel sees seas and rivers not as separate bodies, but as vessels of the same water. It flows with the Earth's ancient pulse, as if it alone knows the secret paths where time and tides converge. The eel's life history is a conduit connecting river to ocean, land to water, swimming along currents linking different spaces across distance. Even our planet's distant past itself echoes through the eel's undulations, its movements mapped by geological epochs. As to why, we must look to German geologist Alfred Wegener. He was the mind behind continental drift theory, the idea that continents were once upon a time a single ancient supercontinent which slowly drifted apart over millions of years. When gathering proof for his theory, Wegener turned to one Johannes Schmidt's research. He felt that eels' great journey must surely stem from a far simpler behavior in a time when Earth's face looked very different. Perhaps before the supercontinent's breakup, eels probably made simple journeys from freshwater to spawn just off the coast. But as continents drifted, eels followed. It's thought that as plate tectonics pulled Europe and America apart over millions of years, the Atlantic Ocean widened, lengthening the short eel migration into the great pilgrimage it is today. At some distant past moment, an ancestral eel for the very first time must have crossed this newly formed channel between the divorcing continents. It marked the beginning of an odyssey that would endure through eel generations, each crossing further than the last by a hair's breadth, tracing through eons an inextricable, invisible connection. One that we, only privy to a tiny sliver of space and time, did not see for millennia, which leaves us pondering, what else are we not noticing?